Hello, everyone. Now is the time. I hope you are having a good time. Uh, we're not going to start immediately. Let's wait a little bit for people to prepare, set up their screen. So we're going to have a small
Get
chat.
up your cup of coffee, get up
Yeah.
your treat.
Yeah. And as a small tip, I would recommend that you watch the live stream from YouTube because the delay is way much less than in LinkedIn. And of course, as you know, you can always chat on the comments. So we will see your comments and we will respond to them if we have the sufficient time during the webinar. But at the end, we will have a dedicated time to look at most of the comments and your questions, of course. So let's do a small testing. I don't see a lot of people joining yet, but the people who I see joining now, can you tell us from where are you joining now? Maybe you just put it in the chat, then we'll see if everything is working correctly. Okay, maybe it will take some time. But maybe I can share a small story to kill some time, like we need to kill a minute or two before we officially start. I'm just going to share with you the story how I met Vlad. So, so we have one person, say from Egypt, Mohamed. Hello. So I was working on the side hustle or the project, which it's called Awatif CO. I started it 2 years ago, and I posted about it online, and I was looking for someone to test it. And Vlad, he was the first person to test the platform actually. And I remember I asked him, like, can you draw like a portrait frame in a parametric way where you can change the width and height and you get the real-time analysis? And I was kind of looking at him doing it because that's the goal of the testing. I kind of felt like I'm interviewing him, but I don't know how you felt about it. Do you remember that day?
Oh yeah, I remember that. I was like, "Hey, let's test it out." I felt like I was very skeptical, so I was like, "Yeah, this is crap," and kind of very. I was very cynical at that point for sure.
Yeah,
But yeah, no, it's nice. It's nice that we met that day. Nice to continue having chats and like seeing how Awatif is developing. You know how we're moving along and trying to progress some of this automation and structural engineering, because it is still, it's been around for a while, the concept of automation, the concept of improving things. But I guess as a lot of people joining and maybe listening later is like they'll be able to relate, it's a slow journey because construction is a slow industry. It takes decades to build things, it takes years to build things. So, and sort of the innovation progress reflects a little bit that pace. It's not bad. It's how it is, and I guess we all have to be sort of humble and kind of carry on, really.
yeah, yeah. We have Ashok from India. Hello, Ashok. Another question before we start. I promise you this is the last question. Which tool you are currently using to automate your structural engineering process? As you might know, we will be talking about Excel, Grasshopper, and Python, JavaScript, C Sharp. So I'm just wondering, what is the tool? We probably didn't cover all the tools, but I can share them in the comments. Ashan from Pakistan, hello. Mohammed, say macros. I don't know. Are you familiar with this tool, Vlad? I've never heard
I
of
haven't
it.
heard of macros, as in like Excel macros, or what kind of macros?
Macros, probably.
VBA, yeah, VBA people, like, yeah, that's great.
Yeah.
That's where we all start, isn't it?
Yeah. Let's start. I think we have 5 minutes. That's a good time to warm up. And so, as you see from the title, automating structural engineering processes and choosing the right tools. I think we deliberately wanted to put this title because there is no best tool. There is always a good tool suited for your job. So we want to explore from our own experience how we use those tools and what are the drawback and benefits. So before going into that, let's briefly introduce ourselves. I am Mohamed Adil. I am a structural engineer by heart. I started my career in Qatar as a structural engineer, designing high-rise building. I was lucky to participate in multiple high-rise buildings in Qatar and gain like a very deep knowledge how buildings and structure are designed. But as a hobby, I'm also a very passionate software developer. So I was doing software development since I was a child. And recently I did a career shift where I completely shifted from from engineering to software in order to understand how to build software in a proper way, working with like actual startup and doing proper software with multiple teams. And I feel I have now the good knowledge to combine combine structural engineering with programming. And I started this uh, platform called Awatif, which exactly does this combination. Vlad, you can introduce yourself.
Hi everyone, I'm Vlad Opanasiuk. I'm a chartered structural engineer here in the UK, London-based. I worked for about 7 years on big infrastructure projects and bridges, some nuclear facilities, scientific facilities, a little bit of everything, sculptures. Then I did a little bit of historic buildings, a little bit on Stadia, so lots of bits and pieces, very generalist experience. But throughout this process, I've been keen on using automation. And as a lot of structural engineers, you start finding ways of how to do things better. And then you start doing VBA scripts, as some of the people in the comments already said, start picking up Grasshopper, Python, eventually sort of picking up these software tools. And so it was sort of a side project for me to learn digital engineering. And then as I was learning, I became, I still don't think I'm a software developer, but I think I'm a sort of side, it's my side hustle sort of to be a software developer in reality. But after 7 years in industry, I started a company called Red, and Red is specializing on structural engineering and some utilization of some of those new digital technologies. I've recently started also a new role at Expedition Engineers on infrastructure consultancy. That's what I will be doing full time. So Red will no longer exist. But yeah, that's my background really.
Great. So the content in this webinar is quite simple. Vlad will give you a short introduction about it, and I will talk about my journey. Then Vlad will talk about his journey using the tools. And at the end, we will have like a summary with a comparison of all the tools and the criteria, and then we can have like a conclusion. And at the end, we will open the Q&A if you have any questions. So Vlad.
Oh, so why this webinar? So the idea is to share some awareness about the tools and languages that exist there, sort of talk about our experience and what we're going to do, what we've done, our journey, how we use these tools, compare them, some pros and cons, some advantages, disadvantages, and really like give an introduction to people on what we've done in our career. And maybe that will, for newcomers to the industry or newcomers to the automation movement, it will give some tips on where to start or maybe where to continue. And for experienced engineers, experienced automators, maybe you'll find some relatable content here and something that you've maybe experienced yourself. And yeah, in terms of questions, feel free to sort of drop questions in the chat and we'll try to answer them as soon as possible, maybe later. So it's quite a free format. Just drop them in the comments.
That's great. So let's get into it. So I started my career in Qatar, as I told you, designing high-rise building, and this is one of the high-rise building I was designing. And the main tool, believe it or not, it was Excel. So with Excel, we were quite doing a lot. And I think it's the most common used tool in engineering and also in other fields of outside of engineering. But why Excel? I think the main reason is Excel is very easy to use. You don't need to have any prior experience. And also with Excel, you can embed reporting. So we don't have to have like a separate process for the calculation and the report. They are all in one process, which enhance productivity a lot. As you can see, this is like a connection design. And with Excel, as many says, like Mohamed and Ashok, you can use VBA, which is a great scripting tool. The reason I used it, it's only to make the code readable, because you still can write your function in the cells, but if you embed this script behind a cell, then it's easy to read. You can comment, which was a huge improvement, but there is no version control of Excel. And if you see here on the right side, every time I change the code, I make a new copy of the whole app. So I ended up having like a lot of versions with the whole app, and that's really a huge waste of resources. And also, like, there is no way to track what I have done. So I had this release log, where every time I change something, I put the version, this is very manual. It was very tedious, and I didn't have a very good time, like enjoyable time with it. And also, Excel is not built to carry heavy calculation like FEM calculation or very complicated CAD manipulation. So I needed to go to a different tool. And you can guess it. It's Grasshopper. When I introduced to the world of Grasshopper, I was amused. How can you draw geometry in 3D space in a very easy way? So I can easily say Grasshopper excel in visualization. You can also link it with other already existing components or plugins like FEM simulation, or export it to other existing app like Robot, eTab, those FEM software in an easy way. But the problem with Grasshopper, which is a big problem actually, it's the code is not reusable. And it's hard to maintain the code in a way that it's easy to read. Sometimes it can get very messy, where engineers call it a spaghetti model. But there are ways to mitigate this, but inherently it can get very complicated. And mostly at each project, you need to write a different script, because there is no way to use different component with export them to another project. It's just very linked to the project you used. And in Grasshopper, like concept like templating for reporting is not there. So you need to use other techniques like Markdown, or rely on Python for reporting. Grasshopper, it's mainly for development logic that linked with geometry. So reporting is not like inherently a geometry. So it's a bit difficult to do reporting. And I'm just mentioning here like one of the main drawback or benefits. It's this time is not sufficient to mention everything here. Then I moved to Python. So that's when I was doing my thesis. I wanted to do something more level, like actual programming, not just scripting. What you do in Excel and Grasshopper, this is like more of a high level scripting. But if you want to do real programming, like develop a robust application, like in this case, I wanted to do FEM simulation for my master's thesis, and I want to investigate like nonlinear effects. So within 2 months, I actually draw the whole code for the FEM simulation for nonlinear geometric nonlinearity in 50 line of code with Python, because it was super easy. And here, as you can see an example, I extended a little bit. I included the dynamic effects, and also it was also quite easy. I mean, Python is very great at scientific computing. Like the equation you wrote, you can just move them to Python and they look alike. And here I've also added some interactivity, like you can use the mouse to interact with the building. So Python comes with version control because it's like a script-based language. You can store it on a system like GitHub. And GitHub, if for the people who don't know, GitHub is a version control system that enhance collaboration a lot. So multiple people can work at the same code, and you can have a full history of your changes in a good way, in an elegant way that's stored on the server. There is a bunch of FEM solver you can use. To mention a few, OpenSeas, Ancestruct. You don't really have to build your own one. But the problem with Python, it's not built for speed. It was built for flexibility, so it's not fast. And the reason it's not fast because the code is compiled line by line at runtime with the interpreter. If you compare it with languages like C++ and Rust, they compile the whole code before runtime, so it's way much faster. But you lose the flexibility. Like if you want to change the code while you are writing it, you cannot do this with C++, but in Python, you can do this. This is why you see Jupyter Notebook, where you can really sequentially write your code. And that's a huge benefit in terms of flexibility, how you write the code, but it comes with this drawback. You can mitigate this drawback by using like a wrapper of C++ library like NumPy. These are wrapper. But if you're building your own solver, then you need to be very careful how you build it. Or I would rather prefer that you write it in another language and wrap it in Python. That's a way to mitigate it. The visualization with Python is not terrible. In 2D, it's great, but if you go to 3 dimension, then you can see the limitation. Especially if you want to build something like more interactive, like drawing your structure, something like ETAB, then it's very difficult to do it with Python, or almost impossible. Then after Python, I wanted to have the speed, like I need to go low level. So I was considering C++, those Fortran languages, but Rust was a modern version of these languages. And I went for it. It's fast. It has source control similar to Python. But the main problem, it's hard to learn. Like I remember I was spending 6 months just trying to understand how to write the code, and at the end I did what I wanted. So productivity was very low with these kind of languages. Then I found the middle ground, which is JavaScript. And if there is something I want you to take from this webinar, it's maybe have a look at JavaScript. It's not well treated with the AEC community, but I see it has a great potential to the level that we decided to use JavaScript in the platform I was working on. Just to give you a small presentation about it, this is not the webinar is not about it, but it's a platform where you can integrate the whole process without relying into other apps when you design or building your buildings parametrically. So it does the FEM simulation, it does the design, it does the drawing, it does the report, all in one app, in one memory. So if you change the slider, everything, it will be instantly fast because you are not relying into other apps, or there is no network layer, this kind of redundancy, we remove them. This make the platform much suited for optimization where you run thousands of iterations. So I will tell you in the next slide why we chose JavaScript for it. First of all, it's a middle ground between Python and C++. It's not as fast as C++, but almost close to it because of the heavy optimization that's done by the engine, the V8 engine, which is developed by Google for their browser, for Chrome browser. And you almost get like native speed. Reporting, because JavaScript work with HTML, and HTML is a templating language. It makes it way much suitable for report. As you can see here in this example, this is an interactive report where you can have tables, drawings, layout. You can do whatever you can. You have the flexibility to present your report in the way you want to do it. UI, of course, JavaScript, it's a UI language, so it's excel in this aspect. And you can do visualization with it, because nowadays the browser become more than just document visualization. They also you can have games, you can have apps like Google Earth, and those are very graphic intensive. So there are a lot of libraries you can use to visualize your structure. Here we're using the most famous one, also maintained by Google. It's called 3ds. But the drawback of JavaScript, it's a bit harder to learn. I don't want to say it's hard, because it's not a low-level language like Rust. It's in the same level of Python. It's not as easy as just using Excel or Grasshopper. You need to learn a little bit about programming. So was it. Sorry. One last point, the ecosystem of JavaScript, it's quite new, so it's not easy to find FEM simulation, but we built our own FEM simulation here for our platform. You can check it out. So to conclude, I think the process from going from easy to hard, it comes with their it's easy, but it's slow and it has a lot of limitation. Like there is always a trade-off. But where you advance more to more advanced tools like Python and JavaScript, you have a lot of limitation. It's fast, but it's a bit hard to learn. So I prefer for you to start with the easy stuff and gradually move to the next step, but maybe not do the same mistake we did. Like if you want to go for a low-level language for the speed, consider maybe a mid-ground JavaScript. It might be suited for your job, but if you really want to have the maximum performance, then you can learn the complexity of how to build an app with memory management. Okay, that was my part. Vlad can tell his part.
You switching to my part.
Yeah.
Great. Well, great to hear your experience, Mohamed. I'll just talk through my journey, which is somewhat similar, but I guess me and Mohamed ended up in slightly different places. Same thing. Started with Excel VBA specifically, our favorite tool, and in a very similar way. And I think it's familiar to probably every structural engineer and other engineers. It's a go-to sort of reporting tool. It's got tables. It's a calculator. You can report. For me, the best part of it is also that you can do vector drawings very quickly. So it's a sort of Swiss Army knife tool for delivering an engineering workflow, and I think that's why it is so popular. And on top of that, you can also do scripting and a little bit of object-oriented programming even. So I think most of us start with macros or writing our own formulae, and then we move on to some of the concepts like object-oriented programming, starting writing our own classes. And Mohamed said you cannot do FEA solver in an Excel, but you can. So when I was working for Covey, big consultancy, it acquired Flint & Neil, which is an older company, and they started writing their FEA programs on punch cards originally. But then, as Excel became more prominent, they also wrote their own internal in-house FEA solver in Excel, where you have to type in specific nodes and connect the nodes in another table, put your loads in another table, put your constraints in another table, and actually it worked pretty well. I think the solver could do linear and non-linear FEA, and it's been used on sort of masts and some of the bridges in the UK. And when I joined Covey and Flint & Neil, I still managed to make use of this tool. It was not very transparent, couldn't access the source, and it was the visualization, the data visualizations of it was poor. I think at the later versions, the developer introduced some of the 3D visualization, but it wasn't great. So the visualization here is actually from a Grasshopper script that I built on top of the results that came out in a text file. So it is possible to write a Excel FEA in Excel, but I would not strongly advise it, to be honest, because of the reasons mentioned by Mohamed in terms of maintaining code, reviewing code, accessibility, and etc., etc. But nevertheless, we all love Excel. It's a good tool for your engineering calculations, and it is, you can do a lot. You can do a lot of analysis, tabular data post-processing. So here, this was used on a very heavy concrete design project. It was useful to process different load cases, including seismic load cases, but it gets heavy. For example, here you can see some plots. The plotting capabilities are good, but have their limitations eventually, and also the performance and scale. So once you're starting to analyze data, the scale becomes an issue. Your workbook will crash. You won't be able to scale it that well. So I wish for this project I knew a bit more Python and great libraries for tabular data management, because at the end of the day, you have a sheet, a workbook, and then a folder of workbooks and a folder of folders, and the data management that you get to scale becomes almost unmanageable. And of course, then this rigid data structure of only having to work in a cell, a table, a sheet, a workbook, it does limit your creativity and does limit what you can achieve. So again, similar to Mohamed, I jumped on Grasshopper, and Grasshopper, I typically see it as a 3D sandbox. Anything that you can do with 3D geometry, Grasshopper is amazing for it. So it does 3D modeling, 2D CAD drawing. I mean, for my own company, for Red, I was doing all my CAD purposes in Rhino. It was great. It's affordable. It's the community is insanely good. If you go online and search for the forums, it's fantastic. It's very easy to learn. People are responsive. It's almost like a little club, like a nerd club that you can join. I love that it has the units and geometric precision, so you can very much control precision and units, something that can be quite difficult in your traditional CAD platforms, and I think Rhino and Grasshopper affects it. You can do visual and text-based programming, and one of the best parts about Rhino is well that it takes a variety of formats. So visualization here, some of the work I've done with Red, which is design of temporary bridges, and through Grasshopper I managed, and some custom scripting in Grasshopper, I managed to build a section tool, a bit of analysis module, and a reporting platform for bridge design. Reporting isn't probably native to Grasshopper, but you can, with Rhino's sort of sheet and drafting capabilities, you can start building some text-based reports. Not ideal, but it's doable. It's fantastic because it's extensible as well. So you have many plugins. So for example, here it was for a small London-based contractor company who were trying to be a bit more innovative with extensions, managed to go from a parametric model into a drawing that's connected to it, and then using third-party plugins, use some of the generative AI to generate your render images. And sort of we were trying to achieve a full design workflow for an extension. So you can build your stuff with Grasshopper. You can use third-party plugins, and there are many, and people have dedicated a lot of hours of time to really make it a great tool. And as I mentioned, the community is just amazing. And trying to switch. I think where you start hitting problems with Grasshopper, I think, is in terms of UI building. And this, for example, is a tool for a generic tower block design. that does sort of your preliminary estimation, different materials such as steel, concrete, and compares cost, environmental impact, and puts it on a scores scale developed by iStruct. So this was hacked because it's a Rhino layout with some Grasshopper controls sort of shared on the screen. There are tools like Human and others that allow you to build a UI, but I think natively it's quite difficult to build and ship a product. So if you're looking to build something then that you send to a client, it becomes very difficult. I think there are advancements with it using Rhino Compute, but then you're starting to go down web development route. So shipping solutions and building UIs is tricky. And I think Grasshopper specifically starts failing at scale because obviously you're computing all of your canvas at the same time, and it is not optimized for performance. And as I mentioned, collaborating and sharing, and as Mohamed touched on, is quite difficult. So there's a lot you can do with Grasshopper, but it starts hitting limitations. And I think this is where I was pushed to sort of move on to C#. And with C#, I've managed to build mainly the C# incorporates all of the functions that you can access in Grasshopper, but in a text-based language, which you can QA, put on GitHub, and do it. It's a bit of a learning curve, but advantages are is that you get all of the great stuff you get with Grasshopper, but also you can build very usable UIs based on Rhino's capabilities. So you can have your WinForms and WPF and also EtherForms. So I used EtherForms because it's cross-platform compatible, and this is what Rhino is using to build their own UI. So there's lots of options for building a sort of very nice user interface. You can ship it. You can ship it as a plugin to the customer. If they have a Rhino license, you can just send them a file. They upload it, and you can even use. They've introduced a package manager now, so it's super easy to build usable applications. And I think once you start developing commercial programs or programs for larger organizations, I think you're starting to look at C# and more strongly typed languages rather than Grasshopper. It performs great at scale. It's not quite as fast as C++, but it's there. I think you don't get the memory management, but it's still very. At least you allocate types, so that's already a great improvement. And yeah, collaboration, sharing, and QA using GitHub is great. I think the disadvantages of C# is obviously that it's a desktop and Windows focused mostly language. It is widely used for all the business applications, so it's not very limiting. And I think most people still use Windows in business cases. It is a big step for non-programmer to learn. I think you as a structural engineer, I've never had a formal education in software engineering, so it does take time. It takes a few months full time and probably a few years, or if you're doing it part time, to really start building something that's usable. So it is a big learning curve, and I think it needs. I think C# also needs a little bit of DIY because it doesn't have a lot of libraries and ready-made plugins that you can just reuse in your code. So it does limit you. So for Python, I have touched Python. I haven't used as much Python as maybe Mohamed. Python, especially combined with Jupyter Notebooks, is a really good tool. Slightly easier to learn than C#. And I think the advantage of it over C# is that it has that huge amount of libraries that you can use in terms of data processing, visualization, plotting, data analysis, some of the machine learning and AI. Is a lot of it is written in Python, and I think there's a huge community of scientists and ML nerds that use Python. So it's a really good tool. It does have disadvantages that it's not a strongly typed language, so it's a bit slower. It's a bit more error prone, and it is a scripting language. It's not really designed to build sort of standalone applications, but you can, like, there are so many tools that are built, like QtPy and others, that enable you to use Python as any other language to develop applications. And just a little bit more about the entire workflow. I think this is to emphasize that no single tool really does the job, right? Like, if you are building a complex engineering workflow, which is what we've done at Covey when working on HS2, at the end of the day, we've managed to build a workflow that automates the design of a footbridge, but it didn't take one tool. It took a plethora of tools. So you start with your standard Excel text-based parameters that then you parse in Grasshopper and Python to produce your central geometric model and a central sort of control model. You can ingest some of the other GIS data, your point clouds, your CAD data into Rhino and Grasshopper, and again, extract some values from it to process in Grasshopper and Python. You then push it through APIs to your FEA packages. I think if you're working in a commercial environment, sometimes the corporate wants to use a proven tool. So sometimes you can't use some of this fantastic libraries for Python or for Grasshopper to do FEA directly. So then you have to connect with your eTabs. We use Lusas because that's standard for bridges, or a GSA or any other tool that you use, or even Plaxis and things like that for geotechnical model. Then you need to do documentation. Documentation is done in BIM typically, and you need to connect to Tekla and Revit. Tekla has a plugin for Grasshopper. Revit has Rhino inside and all the other brilliant tools. And then you have the engineering calculation documentation and the drawing documentation, and each of these steps requires a different tool. And then it's also about combining the tools and making sure they talk to each other through APIs, the application programming interfaces. That is important. And I think so that was done at Covey sort of 5 or so years ago, and the highest level I've achieved, I haven't quite mastered JavaScript or web development. This is something that is of interest to me and I want to develop further myself. But once you start going into the world of more complex applications, applications that are deployed wider than the single organization, then you start looking at JavaScript and other platforms. So I haven't quite got to building my own web applications, but I've used web-based tools like Shapediver, Victor, to start building applications that are deployable to customers. And the benefit of these platforms, I think, similar to what Mohamed described with JavaScript, is that it is accessible and shareable. So you can share it with public, or you can share it with other stakeholders that are non-technical potentially. You don't need to download anything. You don't need to install anything. So it's platform independent. It works in your browser, and you're still using the power of the data and APIs to develop applications. So it's still a big step for a non-programmer, but it's a smaller step than, for example, learning JavaScript and the development time. And you start developing applications that are not for your own internal use or for company use. Then you need to invest into development time, and you start relying on some of the dependencies behind these applications that can slow you down. So that's about it.
Thanks, Vlad. What you share is quite insightful. Like, although we did the practice session, but this time I also gain more insight. So thanks for that. So I think we are a little bit out of time, so we will keep it a bit short. So I don't want to have a long video at the end. We will go through the comparison fast, and maybe we'll take 1 or 2 questions. So how about I quickly summarize Excel, Python, and JavaScript, and you, Vlad, summarize Grasshopper and C#. I think this is what we are more familiar with. So for Excel, as we showed, it's easy to use. It's way much used by like it's actually in every company, so it's very accessible. But the drawback, it's not a scripting, like you cannot use version control and reuse what you have done in like the script. It's just embedded inside the app. So that's one of the main drawback. And Python, it's kind of, as you can see here in the table, it has a lot of greens. So I think the only thing maybe it's missing is the drawing, as we say that. So it's like a good choice if you want something that is safe, I would say. And closely to it, also JavaScript has a lot of greens. It does miss a little bit in the ecosystem, but I believe it's booming because it's not only the engineering industry who are developing, but a lot of other like industry, they are using web application because they are way much accessible. This is the main thing, like the web apps are way much accessible. Like you can see what Figma did to Adobe, or what Google Sheet did to the traditional Excel. So there is a trend there. And yeah,
Sure,
Vlad.
and in terms of Grasshopper, so Grasshopper is a easy to start. It's a visual programming language, so you don't need to write lines of code. I think for people who are more visual thinkers, who are used to dealing with drawings and graphic information, it's very easy to learn. Great community, fantastic for things like visualization, dealing with geometry, but it does lack that version control, reusability, the actual conveniences of the development process and the QA process that you can get with scripting and code and properly typed languages. And of course, it's a little bit slow in performance. And with C#, and you can build completely standalone applications for any purpose. Just build anything, and especially if you combine it with Rhino, which is the host program for Grasshopper. If you combine it with Rhino, then you get all of the advantages of visualization, although somewhat limited by having to develop some of your own modules. But I think it is a very good choice, but it is much harder to learn for a non-programmer because you're starting to learn new concepts, and it takes some time to get up to speed and to actually be productive and to build things that are useful in your day-to-day, which we don't all have the luxury to do.
Cool. So that was it. I hope you guys learn a lot from it. And here a small repo where we try to gather all the resources and the tools in one repository where you can find a place to investigate and play with existing tool. Maybe if you also have any suggestion, make a pull request and we can make it grow it. So any question? Now the time for the crowd. I see one question here. Can you use JavaScript to create standalone desktop application? How easy it is to create GUI, forms, etc. Yeah, of course you can use JavaScript to build the desktop application. The WhatsApp app, if you're using WhatsApp, the desktop one, it's actually built with JavaScript. And there is a famous library. Yeah, as you can see from the comment from Mohamed, Electron. Yeah, you can use it that can help you build those desktop app. So,
but is it still running in the browser? Just for a question from me, is if you're using it, if you're building in JavaScript, you still relying on your Chrome to run the program?
No. So like the app itself has an embedded browser.
Oh, okay.
So you don't really need to link it to the browser.
Mm-hmm.
Another question from, could you recommend me material to learn from VBA to Python courses or books related to structural engineering? Well, that's a good question. But I don't know.
I would start. I did an MIT edX course on Python. That really helped me. I think it's free. You can find it. I think there's the stuff that I think Timo Harbo and Christoph on LinkedIn, search for them. They do some courses specifically for structural engineers, but for if I were you, I would maybe not focus straight away into structural engineering specific applications. Perhaps if you have time, do an edX course on it, because it gives you a lot more background on programming and software engineering. It will make you a better programmer. But I think for a quick fix, if you're into structural engineering, then Timo and Christoph on LinkedIn, search for them on LinkedIn. You'll probably find Christoph does a lot of Grasshopper stuff, and Timo does some Python for engineers courses. Start there. I think that's probably the best that I know so far.
Another question from Mohamed: can you share some JS library for FEM? That is an interesting question, because this is what we faced at the beginning when we built Awatif. We couldn't find any library to do FEM, so we built our own one, and it's actually, we went a bit far with it. We start with bar element, now we have beam, now we have shell, so we kind of complete the picture, and soon we'll do dynamic and nonlinear. So if you want to get it, it's for free. It's open source with MIT license. You just Google awatif.co and you will find the code there. I think that's it. We're already approaching 50 minutes. They will be recording directly after this session, both in YouTube and the channel of Awatif, and also in LinkedIn. So, anything to add, Vlad, before we close?
No, nothing from me, actually. Thanks for listening, and any future listeners that will follow us on YouTube and other platforms. And yeah, if you have any questions, obviously feel free to throw the comments in, add us on LinkedIn, and just throw messages in there. And yeah, thanks for your time, and thanks for listening.
Yeah, thanks a lot. And we will be sharing more of this kind of webinar. And we have a small community if you want to join us, like a LinkedIn group where you can talk with people like Vlad and me in person. Just reach out to us. Thanks, and see you soon.